integration of communication and computer network. What is meant by network? Network is a combination of hardware, software that sends data from one location to another. The hardware consists of physical equipment that carry signals from one point of the network to another, and software consists of instruction sets that make possible the services that we expect from the network. Next one is layer. We use the concept of layers in our daily life. Example, when two friends want to communicate instantly, the process of sending a letter from one friend to another. Consider here, if the task involves in sending a letter from one friend to another. Here at the sender side, three layers are there: higher layer, middle layer, and lower layer. And at the receiver side also, three layers are present: lower layer, middle layer, and higher layer. At sender side, when sender writes a letter, insert the letter in an envelope, writes the sender as well as the receiver addresses, and drops the letter in a mailbox. At the middle layer, the letter is picked up by a letter carrier and delivered to the post office. At the lower layer, the letter is sorted at the post office and the carrier transports the letter. In the other side, that is at the receiver side, at lower layer, the carrier transports the letter to the post office. When it receives up to the receiver as a parcel from source to destination. At middle layer, the letter is sorted and delivered to the receptionist's mailbox. The recipient's mailbox. And at higher layer, the receiver picks up the letter and opens the envelope and read it. So this is the simple layered task in letters sent by sender to the receiver. Next one, network model, which is known as OSI model. It was established in 1947. The International Standard Organization, that is ISO, is a multinational body dedicated to worldwide agreement on international standards. An ISO standard that covers all aspects of network communications, such as Open System Interconnection model, was first introduced in the late of 1970s. Such model gives the layered architecture, which can be explained over here. There are different 7 layers of the OSI model, from physical to application. Physical layer, data link layer, network layer, transport layer, session layer, presentation and application layer. Here, the interaction between layers in the OSI model is shown. First, peer-to-peer processes. At the physical layer, communication is direct. As shown in the figure, device A sends a stream of bits to device B to intermediate nodes. At higher layers, communication must move down through the layers on device A over to device B and then back up through the layers. Each layer in the sending device adds its own information to the message it receives from the layer just above it and passes the whole package to the layer just below it. At layer 1, the entire package is converted to a form that can be transmitted to the receiving device, and the receiving machine, the message is unwrapped layer by layer, with each process receiving and removing the data in per key. Interfaces between layers. The passing of the data and network information down through the layers of the sending device and back up through the layers of the receiving device is made possible by an interface between each pair of the adjacent layers. Each interface defines the information and services a layer must provide for the layer above it. Organization of the layers is divided into two groups. First, layer 1, layer 2 and layer 3 are the network support layers, and layer 5, 6, 7 are the user support layers. Layer 4 is the transport layer, links the two subgroups and ensure that what the lower layer have transmitted is in the form that the upper layer can use. Next, an exchange using an OSI model is shown in the diagram. This diagram shows the overall view of OSI layers. D7 means the data unit at layer 7. D6 means the data unit at layer 6 and so on. The process starts at layer 7, that is application layer, and moves down from the layer to layer in descending as well as sequential order. At each layer, header or possibly trailer can be added to the data unit. The trailer is added only at layer 2 when formatted data unit passes through the physical layer by adding error bins. It is changed into an electromagnetic signal at the physical layer and transported along a physical link. It is encapsulation. A packet, that is nothing but header and data at level 7 is encapsulated in a packet at level 6. The whole packet at level 6 is encapsulated in a packet at level 5 and so on. In other words, data portion of a packet at level n-1 carries the whole packet, that means data and header, maybe trailer also, from level n. This concept is called as encapsulation. Next, different layers in the OSI model. We will discuss here all layers one by one. First, physical layer. Physical layer coordinates the function required to carry a bit stream over a physical medium. It deals with the mechanical as well as electrical specifications of the interface and transmission medium. It also defines the procedure and functions that physical device and interfaces have to perform for transmission to occur. Different characteristics or responsibilities performed by the physical layers are: physical characteristics of interfaces and medium, representation of bits, data rate, synchronization of bits, line configuration, physical topology, as well as transmission mode. The physical layer data consists of stream of bits, that is sequence of zeros and ones, with no interpretation. The interface between the devices as well as transmission medium defined by the physical layer. Transmission rate is nothing but the number of bits sent at each second, is also defined by the physical layer. Synchronization of bit means sender as well as receiver not only must use the same bit rate but also must have synchronized at the bit level. That is, sender and receiver clocks must be synchronized. Line configuration. The physical layer is concerned with connection of devices to the media. That is point-to-point configuration. When two devices are connected through a dedicated link, as well as multi-point configuration, a link is shared among several devices. Physical topology. The physical topology defines how devices are connected to make a network. Devices can be connected by using different topologies such as mesh, star, ring, bus, hybrid, etc. Transmission mode. Physical layer can also define the direction of transmission between two devices such as simplex, half duplex or full duplex. Next, data link layer. In the given diagram, at the data link layer, data is received from the network layer, and from this data link layer, data is passed to physical layer. Some of the responsibilities handled by data link layer such as framing, physical addressing, flow control, error control as well as access control. Framing is nothing but the message or data is going to combine in different manageable data units called as frames. Physical addressing is nothing but if frames are to be distributed to network different systems on the network, the data link layer adds a header to the frame to define the sender and receiver of the frame. Flow control. If data rate, which is the data absorbed by the receiver, is less than the data which is sent or produced by the sender, the data link layer imposes a flow control mechanism to avoid overload on the receiver. Error control is also a responsibility to handle by data link layer as well as access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any given time. Next, data link layer gives here hop to hop delivery, that is node to node delivery. When two machines, that is A and F, communicate with each other, they are going to connect within that path with intermediate nodes such as B, E and links. To send data from A to F, 3 deliveries are made here. First, data link layer at A sends a frame to the data link layer at B, that is router. Second one is the data link layer at B sends a new frame to the data link layer at E, and finally the data link layer at E sends a new frame to the data link layer at F. Their frames that are exchanged between three nodes have different values in the headers. The frame from A to B has B as the destination address and A is the source address. The frame from B to E has E as the destination address and B is the source address. From E to F, it has F as the destination address and E as the source address. The values of the trailers can also be different if error checking includes the header of the frame. Next, network layer. According to the diagram, from transport layer, data is received in the form of packets from the transport layer, and this data is passed to the data link layer in the form of packets. The responsibilities handled by the network layer as logical addressing and routing. What is meant by logical addressing? The physical addressing implemented by the data link layer, which handles the addressing problem locally. If a packet passes to the network boundary, that is with another network, then we need another addressing system to distinguish the source and destination system. The network layer adds a header to the packet coming from the upper layer that among the other things include a logical address of the sender as well as the receiver. The next responsibility is routing. When independent networks or links are connected create a inter-network, that is network of networks, or a large network in connecting devices, or it is also called as routers or switches. They route or switch the packet to their final destination. Next one, some of the responsibilities of the network layer are mentioned here: source to destination delivery, logical addressing, as well as routing. As shown in the diagram, the network layer A sends the packet to the network layer at B. When the packet arrives at router B, the router makes a decision based on the final destination, that is F, of the packet, as well as the router B uses its routing table to find that the next port is the router E. The network layer at B therefore sends a packet to the network layer at E. The network layer at E sends the packet to the network layer at F. Next is transport layer. Transport layer is responsible for process-to-process delivery. The process is an application program running on the host, whereas the network layer identifies it as source to destination delivery of individual packets. It does not recognize any relationship between these packets. But at the network layer, here, according to this diagram, from session layer, data is going to receive at the transport layer, and data is passed to the network layer in the form of segments. The responsibilities handled by the transport layer are service point addressing, segmentation, reassembly, connection control, flow control, as well as error control. The network layer gets each packet to the correct computer. The transport layer gets the entire message to the correct process on that computer. Computers often run several different programs at the same time. For this reason, source to destination delivery means delivery not only from the computer to the next, but also from a specific process that is running program on one computer to a specific process that is running program on the other computer. The transport layer header must include a type of address called as service point address or port address of that running program. Segmentation and reassembly. The message is divided into transmittable segments, each segment containing a sequence number. These numbers enable transport layer to reassemble the message correctly upon receiving at the destination, and used to identify and replace packets that were lost in the transmission. It is also handle connection control, flow control, as well as error control. In the given diagram, reliable process-to-process delivery is given. At network layer, this transmission is known as host-to-host delivery, and at transport layer, it is known as process-to-process delivery. The same thing is noted here at transport layer, which identifies some responsibilities such as service point addressing, that is port address, flow control, error control, segmentation, reassembly, and connection control. Next is session layer. Session layer is responsible for dialog control and synchronization. The session layer allows two systems to enter into a dialogue, that is, allows the communication between two processes to take place in either half duplex or full duplex mode. Next is synchronization. The session layer allows the process to add checkpoints, that is synchronization points, a stream of bits For example, if a system is sending a file of 2000 pages, it is advisable to insert checkpoints after every 100 pages to ensure that each 100-page unit is received and acknowledged independently. In this case, if crash happens during the transmission of page number 523, the only pages that need to resend after system recovery are pages from 501 to 523. Pages previous to 501 need not be resent because after 100 checkpoints, every 100 pages are received correctly and acknowledged. The next is presentation layer. Presentation layer is concerned with the syntax and semantics of the information exchanged between two systems. The responsibilities handled by the presentation layer are translation and encryption as well as compression. Translation means the processes, that is running programs in two systems, are usually exchanging information in the form of strings, numbers and so on. The information must be changed to bit streams before being transmitted because different computers use different encoding systems. The presentation layer is responsible for interoperability between different encoding methods. This layer at the sender changes the information from sender dependent format into a common format, and the presentation layer at the receiving machine changes this common format into receiver dependent format. Next is encryption. To carry sensitive information, a system must be able to ensure the privacy. Encryption means the sender transforms the original information to another form and sends the resulting message out over the network. Decryption reverses the original process to transform the message back to its original form. Next is compression. Data compression reduces the number of bits contained in the information. Data compression is particularly important in the transmission of multimedia such as text, audio as well as video. Next is application layer. Application layer enables the user, whether human or software, to access the network. It provides user interface and support for services such as electronic mail, remote file access and transfer, shared database, as well as other types of distributed information services. The responsibilities handled by the application layer are network virtual terminal, file transfer, access, mail services as well as directory services, which are noted here. In network virtual terminal, it allows user to log on to remote host. Application creates a software terminal at the remote host, and the responsibilities such as mail services also handled by the application layer. The whole summary of layers is mentioned over here from physical to application layer. So we can read it one by one. Physical layer is used to transmit each core medium, and it provides mechanical as well as electrical specifications. Data link layer is used to organize bits into frames, and it provides the hope-to-hope delivery. Third one is the network layer. To move packets from source to destination as well as to provide inter-networking, network layer is used. Fourth one is the transport layer. To provide reliable process-to-process message delivery and error recovery. Fifth one is the session layer. To establish, manage and terminate the session. Presentation layer is used to translate, encrypt and compress data. And last one is the application layer, which is used to allow access to network resources. In this way, we have seen different network models such as OSI model and its different layers. That's why it is also known as layered architecture. Thank you.